Curve C has the equation y equals 3 over x plus 5. The line L, y equals minus 2x plus c, where c is a constant, does not intersect with c. We need to find the range of possible values of c. So even though the question says does not intersect, the fact it's even mentioning the word intersect makes me think simultaneous equations. I just know that when I do it, I won't get any answers because they don't intersect. But then I can start to consider the discriminant. So this question is simultaneous equations and discriminant. So instead of if y equals minus 2x plus c, I could substitute that in here. So let's do that. I'll get minus 2x plus c is equal to 3 over x plus 5. Now, I don't like that x on the bottom there. I don't like fractions. Let's get rid of that. So let's times everything through by x. So minus 2x times x is minus 2x squared. C times x is cx. The 3 over x times x is just 3. And the 5 times x is 5x. Right, let's add 2x squared to both sides. And let's subtract cx from both sides. And we've still got the 5x over here, and we've still got the plus 3 over here. Now, like I said, I've got this quadratic, and I know that there are no solutions to this. So I know that b squared minus 4ac is negative. So now I'm interested in what's a, what's b, and what's c. Remember, a is the coefficient of the x squared. So a is 2. Now b is the coefficient of x. But notice I've got two x terms here. So I need to deal with that. I'm going to factorise the x outside. So if I take an x outside here, then I'd have a minus c plus 5 here. So this is my 5x, and this is my minus cx, the 5x and the minus cx. All I've done is I've just factorised the x out from here and here to write it there, and that's left me with the minus c plus 5 on the inside. And that's good because now, like I said, the a is 2, this is the b, this is the c. So a equals 2, b equals minus c plus 5, and the c for the discriminant is 3. Don't get mixed up between the c here in the equation and the c here in terms of the discriminants. They are different c's. Right, let's go, let's do it. So b squared minus 4 times a times c. Right, let's expand those brackets. So minus c times minus c is c squared. Minus c times 5 is minus 5c, and then double it. And the 5 squared is 25. Then we have minus 4 times 2 is minus 8, times the 3 is minus 24. Collect up those like terms. Right, I now want to solve this equation, which I could do by either quadratic formula or using my calculator or completing the square. I'm going to complete the square to find my roots. So I'm going to complete the square to find the roots. So I'm going to say c minus 5 squared minus 25 plus 1. So c minus 5 all squared minus 24. We're using this to find the roots when it equals 0. Then we'll worry about the fact it's an inequality rather than an equation. So c minus 5 squared is 24. Let's square root both sides. So c minus 5 is equal to plus or minus the square root of 24, which is the same thing as 2 root 6. Let's simplify that third. Root 24 is the same thing as 2 root 6. And now we will add the 5 to both sides. So these are my two roots. We've got 5 plus 2 root 6 and 5 minus 2 root 6. Now let's think about the fact that this is an inequality, so I should draw a little sketch. So 5 plus 2 root 6 is over here somewhere. 5 minus 2 root 6 is down here somewhere. Doesn't really matter. It's going to look something like this. And we're looking for when this discriminant is less than 0, where it is negative. It's negative in between these two values, in between 5 minus 2 root 6 and 5 plus 2 root 6. So therefore my answer is that c has to be bigger than 5 minus 2 root 6, but less than 5 plus 2 root 6. If c is between those values, then this straight line will never intersect with that curve.